What's going on YouTube? Coach Carr here bringing you another video on our road to knowledge. See what I did there? Now this one is finishing up trig ratios and we go over pages 18 through 21 in our note packet. Now I do apologize now because the first couple things I did on page 18 didn't come out very well. It was a little blurry. I do leave a portion in there though where it's not blurry so that you have time to copy everything down. So again, I do apologize for that. Alright, so for this lesson, there's the learning target and the success criteria. The learning target is to find trig ratios and solve problems involving right triangles. Now the success criteria is you'll be successful when you can use trig functions in real world problems. So you're going to use it to find lengths and angles. Okay, so now we're going to be using trig to solve real world problems. Now, before we can do that, we first need to know two things. One, the angle of elevation, and what the angle of depression is. So the first one, angle of elevation, it says when you stand and look up at the point in the distance, the angle your line of sight makes with the horizontal line, which would be the ground. So what we can draw to give ourselves an example, I'm going to draw a little eye, make it look fancy, and this eye is supposed to be looking up at something. So maybe it's looking up at a building, who knows what. But the angle that which it looks up at whatever it is, that's your angle of elevation. So this angle right here would be the angle of elevation. You're looking up. I like to think of it as an ant looking up somewhere. Angle of depression, it's when you stand and look down at a point in the distance. The angle your line of sight makes and a horizontal line. So let's say that you're standing on top of something. You're looking, you're real high, you know, lit. So since we're high up, I'll go ahead and give it some little red. You know, lit, bruh. Now this one is looking down at something. So when it's looking down, the angle of depression is actually, so if I were looking across, it would be this angle right here. Now that angle is not inside of the triangle, so we have to make it so it is. So the angle of depression would actually be right here because of alternate interior angles. Because the sky and the ground are going to be parallel to each other. So that's how we got the alternate interior angles. So really, whenever you hear angle of elevation or angle of depression, it's going to be in the exact same spot. So as long as you remember that, you should be good. And you also need to know that whenever you use trig, it has to have, or the trig that we're using, it has to have a right angle. Okay, so now we're looking at number 1 on that same page. It says the Washington Monument in Washington, D.C. is surrounded by a circle of 50 American flags that are each 100 feet from the base of the monument. The distance from the base of a flag pole to the top of the monument is 564 feet. What is the angle of elevation from the base of the flagpole to the top of the monument? Label the diagram with the lengths given in the problem, showing all your work and calculations, and round your answer to the nearest degree. So if I'm finding a degree, that means I'm going to be using the inverse function. So whenever you see that you're finding one of the angles, you're doing the inverse function. So angle of elevation, remember that's like the eye where it's looking up somewhere. So I am going to be trying to find this angle right here. Now I also want to label everything. So they told us that it's 100 feet from the base of the monument. So this flag to the base of the monument is 100 feet. I was also told that the distance from the base of a flagpole to the top of the monument is 564. So the base to the top is 564 feet. So some things that we need to know is which ones are adjacent, hypotenuse, and opposite. So the hypotenuse is always across from the 90-degree angle, so this one's our hypotenuse. The other side that touches the angle would be our adjacent. And then across would be the opposite. So everything is labeled now, so we will be able to solve this. So we have a side length that uses adjacent and hypotenuse. So if you don't remember which one uses adjacent and hypotenuse, feel free to write that SOHCAHTOA that I told you about before. This helps you know which one goes with which. You also have on the reference sheet that you even get on the EOC where it tells you which ones go with which. So adjacent and hypotenuse goes with cosine. And remember that I'm trying to use the inverse function, so I need to have the cosine to the -1. Now, it goes adjacent over hypotenuse, so adjacent is 100, and the hypotenuse is 564. Now, when I put that into the calculator, what I get is 79.787. Now, it said round your answer to the nearest degree, so that's the nearest whole number. So that would be 80 degrees. So the angle of elevation would be 80 degrees. So I noticed after the fact that it seemed to come out a little blurry on these ones, so I just want to give you a chance to hopefully see it now where it's not so blurry, and this if you need to pause it to take a time to rewrite everything, feel free. Okay, so now we're on the last problem on this page. It says a man on a cliff is looking down at a boat at an angle of depression of 37 degrees. How tall is the cliff if the boat is 550 feet from the base of the cliff? So first thing I'm going to tell you to do whenever you have something like this is to draw it out. So you have a dude on a cliff looking like a Creed music video, you know, with arms wide open. If you don't know what I'm talking about, you can watch it and you'll see they're on a cliff the whole time. So he is supposed to be looking at a boat, and the boat is 550 feet away from the cliff. So 550 feet away from the cliff. And homie is looking at a angle of depression. So that's right there, but remember we used that alternate interior angles with it. So we're looking at this angle right here, and it's an angle of 37 degrees. They want to know how tall the cliff is. So what we are trying to find is this right here. So next thing I'm going to do is I'm going to go ahead and label each of the things. So this would be our hypotenuse. I know this because it will be the longest side and it will be across from the right angle. This would be the adjacent because it's the other side that's not the hypotenuse that's touching the angle. And here, what we're trying to find, the height of the cliff, is the opposite. So now we want to look at what we have. We have the adjacent. We have the angle, so we're not going to use an inverse function. We're going to use one of the regular ones. And the only one that uses adjacent and the opposite is tangent. So what we're going to have is tangent of 37 that came from our angle equals opposite, which we don't know yet, so I'm going to keep it as x, over adjacent, which is 550. So next step would be to multiply each side by 550 because I'm trying to get rid of this fraction. So that cancels it out there. So you have 550 tangent of 37 equals x. And when you put that in, you're going to get 414.4547 equals x. So it would be 414.4547 feet. All right, so we are now on page 19, number 3. This one says, from the top of a 210-foot lighthouse, a keeper sights 2 boats coming into the harbor, one behind the other. The angle of depression to the more distant boat is 25 degrees, and the angle of depression to the closer boat is 36 degrees. Draw and label a diagram that models the situation. Then determine the distance between the 2 boats, showing all your work and calculations. Round your answer to the nearest tenth of a foot. Then convert the distance into feet and inches. So first thing, you have a word problem, you don't have a picture. I'm going to tell you to draw it out. So again, you are going to get to see Coach Carr, the artiste. So they told us that we have a lighthouse. So I'm going to draw my lighthouse real quick. Ooh, fancy. And there's supposed to be a keeper inside of it, the keeper of the lighthouse. He sees 2 boats in the distance. One boat is going to be farther than the other. The farther boat, so if I'm looking down here, the farther boat, here's my little C, is supposed to be having an angle depression of 25 degrees. So remember that the angle depression is when, if he's looking across, it would be this right here. But I want it to be inside of my right triangle, so it would be actually here. So this angle is 25 degrees from looking from here down to the boat. That's 25 degrees. The angle from here to this boat is 36 degrees. So the few other things that I want to make sure I label is they told us how tall it was. So the lighthouse is 210. So I want to make sure I label that as well. Then now I'm going to find the distance from each of the boats to the base of the lighthouse. So first, I want to label each of them. So I have the hypotenuse. If I'm looking at this angle here, this would be the adjacent. And the lighthouse would be my opposite because it's across from that angle. So first one, let's say if I were doing the 25-degree one, if I'm trying to find this distance down here, I need to use the adjacent, and then I'm going to want to use the opposite because that's something that I actually have a value for. So the only one that uses opposite and adjacent is tangent. So for the first one, I'm going to have tangent 25 degrees equals, now it goes opposite over adjacent, so opposite is 210, and the adjacent is what I'm trying to solve for. So now your next step would be, I'm trying to get rid of this fraction, so I'm going to multiply each side by x. That cancels it out right there. And now you have x tangent of 25 equals 210. Divide each side by the tangent of 25 so that we get x by itself. And x equals 210 over the tangent of 25. Another way, and so you don't have to do this amount of work every time, is if you remember if x is in the bottom, in the denominator, I can just replace the tangent 25 and the x, and that's what's going to happen each time when x is in the denominator. All right, so when I put this in, I'm going to get x equals 450.3464. Now, they told us to round your answers to the nearest tenth, so that means that this one is 450.3 feet. So the first boat is 450.3 feet away from the lighthouse. So that's the first boat done, the further boat. The next boat has 36 degrees. Now it still has, this is the adjacent, that is the hypotenuse, and this is the opposite. So I'm still going to use tangent. So tangent, this time 36, equals 210 over x. Same method, multiply each side by x. That's so that it cancels out there. X tangent of 36 equals 210. Divide each side by the tangent of 36 so that x gets by itself. X equals 210 over the tangent of 36. When I do that in the calculator, I get 289.0402. I'm going to round to the nearest tenth, so the only thing that could change is a 0, but since it's a 4 next to it, it's not going to change. So really, this one's 289 feet. So the main thing that I was looking for is what is the distance between the two boats. So now that I know the distance for both of them to the lighthouse, I can just subtract those with each other, and that's going to get me the distance between them. So now I'll do 450.3 minus 289, and that's going to get me 161.3. Now, 161.3 feet, the last thing they wanted to do, the little cherry on top, is convert the distance into feet and inches. So we have 161 feet. We just have to figure out how many inches 0.3 is. So the way we do that is we do 12 times 0.3, because there's 12 inches in 1 foot, we have 0.3. That's going to get us 3.6, and I'm going to round up to 4. So 161 feet, 4 inches. And you might want to put a little star or something next to this one, because you'll probably see a question similar to this on your test. Okay, so the next problem we're looking at is number 5 on page 19. It says a wire 77.4 meters long is attached to the top of an antenna that is 71.3 meters high. Find the angle that the wire makes with the ground. So, first thing we're wanting to do, you have a word problem, no picture. Let's draw it out. So, I have a wire that's attached to this antenna that is 71.3 meters high. Now, if the wire is attached to the top of it. It's attached to the top and going down. So that means that this is actually going to be, this 77.4 is going to be the hypotenuse. And then you have the ground right here. What we're trying to find is the angle that the wire makes with the ground. So this angle right here, or the angle of elevation. That's what we are trying to solve for. So in order to solve this, we need to know which ones are hypotenuse, adjacent, and opposite, so we know which one to use. So this one, the hypotenuse is the 77.4. I knew it was the hypotenuse because it's across from the right angle. Adjacent is going to be the other side that's also touching that angle, so this one would be the adjacent. And then opposite is going to be across from it, so this is my opposite. If I'm trying to find an angle, we have to use the inverse function. So we just have to know which function to use, sine, cosine, or tangent. So since we have one that uses opposite and hypotenuse, the only one that uses both the opposite and hypotenuse is sine. So we're going to be using the inverse of sine. And sine goes opposite over hypotenuse. So 71.3 over 77.4. When I do that, I'm going to get 67.1047 degrees. Now, if they ended up telling us to round to the nearest whole number, then it would be 67 degrees. Just depends on how they word it. Okay, so now we're looking at number 12 on page 21. It says a 30-foot ladder is leaning against a building so that its angle of elevation is 50 degrees. At what height above the ground does the ladder touch the building? So you have a word problem, you don't have a picture. We are going to first draw it out. So I'm first going to draw my building. Give it a nice roof. Fancy. There's its windows. I'm trying to be an artiste for y'all. And then the door. Now, this building is supposed to have a ladder on it that is 30 feet long. So this ladder is leaning against a building and it's 30 feet. And the angle of elevation that it has is 50 feet. Or if not 50 feet, sorry, 50 degrees. So that's 50 degrees, we have the 30 feet. What we're trying to find is at what height above the ground does the ladder touch the building. So how tall is it from the ground to where the ladder touches? So this is the side we're trying to solve for. So in order to do this, we're going to have to figure out which trig function we're going to use. And we need to label our hypotenuse, adjacent, and opposite based off of this angle here. So hypotenuse is always going to be across from the right angle. It's going to be our longest side. So the 30 feet is our hypotenuse. The adjacent, the other side that's touching the angle, that's not the hypotenuse, is right here. And then opposite is what we're trying to find, the x. So now we look at what we're trying to find and the information we've been given, and it uses opposite and the hypotenuse. When we use our SOHCAHTOA, or we know that opposite and hypotenuse goes with sine. So we are going to have the sine, and the degree is 50, equals opposite over hypotenuse. So I don't know what the opposite is, so I'm going to keep it as x, and the hypotenuse is 30. So next step, multiply each side by 30 to get rid of this fraction and get x by itself. So now you have 30 sine of 50 equals x. When I do that, I am going to get 22.98133 feet. So the ladder is touching that building 22.98133 feet. Okay, so the last one that we are looking at is going to be number 14 on page 21. This one says an airplane is flying at an altitude of 1,500 feet, or 15,000 feet. If the plane's horizontal distance from the airport is 110,000 feet, find the angle of depression at which the plane must fly to make it to the airport. So we have the word problem, we don't have a picture, so we are going to make one. So we have an airplane. Here's where the little wings. Ooh, yeah. Pretty darn tootin' good. Now, the airplane is supposed to be flying at an altitude of 15,000. So 15,000 feet up into the air. The horizontal distance from where it is to the airport, so horizontal going across, is 110,000. What I'm trying to do is find the angle of depression. So angle, we're dealing with an inverse function. Remember that when you do this, angle of depression is right here technically, but that's not inside of my triangle. I need to make it inside my triangle with alternate interior angles. So the angle I'm trying to find is right there. So in order to know which inverse function I want to use, I have to first label my hypotenuse, adjacent, and opposite. So hypotenuse is always across from the right angle. So there's my hypotenuse. Adjacent is the side that's also touching the angle that isn't the hypotenuse. So this would be my adjacent. And then the altitude would be the opposite. You notice that the altitude started from the top, made a 90-degree angle. Yeah, see? Bringing vocab into it. Now, the only two that we have is the opposite and adjacent. The only one that uses both opposite and adjacent is tangent. So I want to do the inverse function of tangent, so tan 1 times the opposite over adjacent, so 15,000 over 110,000. When I do that, I am going to get 7.7651 degrees. Or if they wanted me to round to the nearest degree, they didn't say to necessarily, but if they did, then it would be rounded up to 8 degrees. Thank you again for watching. This is the last video in this playlist for right triangles. So make sure that you do the rest of your exit slips that you haven't done yet, and then the other problems that are in that packet is practice for you. Now, if you have any questions, please let me know. But again, make sure to ring that bell, hit that notification bell, like, subscribe, all that jazz. And again, I hope you enjoyed.